Right, hi guys. Today we're going to talk about exothermic reactions. We're going to look at them in a bit more detail. So you should recognise the term exothermic from last time. And just a quick reminder that exo means exit and thermic means heat. So that means these are chemicals that this is a reaction that releases heat to the environment. Okay, and that, let me just be really clear on that. That means that when you go through this reaction, the surroundings will heat up. So you'll be able to measure a temperature change, an increase in temperature. So let's give an example that we looked at a little bit last time. We're going to go into a bit more detail about this. So if we've got a Bunsen burner, okay, like that. A gas pipe, then we know that when we set it on fire, when we light it, you're going to see light. Okay, so light energy is released. That gives you a clue as to whether something is exothermic. When you are in engineering, for example, obviously if you're heating something up, you can see it glows, is giving out heat. Okay, and it's the same thing. If you can see light being released, then it's usually an exothermic reaction. Okay, so we've got heat and light given out to the surroundings here. Okay, so it's exothermic. And let's also then think about what's actually going on here. We've got going into the Bunsen burner, we've got methane, which is CH4, and from the air we've got oxygen. And when they get up to the top here, they both go up this pipe, and when they get up to the top, they react together. The atoms are rearranged, okay, and bonded together in a different way. And this releases the heat energy and the light energy, and it also releases CO2, okay, and H2O. And from that, what we can do is we can construct an equation, a chemical equation, using the symbols that we've got on here. So we've got methane, CH4, reacting. Okay, we've got oxygen, O2, and we know that it is turning to CO2 and water, H2O. Now we can see that's not balanced, so let's balance that quickly. We've got C, H, and O. Okay, we've got one of those there, we've got one here. We've got hydrogen, 4 on that side, and on this side we've got 2, and then on this side we've got 2 oxygens, and then we've got 3 oxygens this side. So we need to do a little bit of accountancy here. I'd think that here, let's just look down the list, we need to balance the hydrogen. So we've got 2 this side and 4 that side. Easiest thing to do there is just double the amount of water. Okay, and we've got 4, but we've also doubled the amount of, we've also got 2 oxygens here instead of just 1 now. So we've got 2 plus 2, which is now 4. That now makes it easier to balance this side, just by sticking a 2 in front of that. Okay, and now we've got 4. So we've balanced that equation. I'll just rub out my accountancy. That's a really nice method to use. It means that you keep a track of what's going on either side here. Even if my video doesn't show it perfectly. There we go. Okay, so I can now rub out my accountancy here. Okay. And I'll give you an additional piece of information. This energy change gives out 882 kilojoules per mole. Okay, if you remember what a mole is just a big number. Okay, and if we burn 1 mole of methane, we're going to get 882 kilojoules of energy released. Why is this a negative symbol? The simple answer is it's a negative symbol because it's the chemicals that are losing that energy. Okay, this may not make sense to you because you think, well, actually, it's getting hotter. But it's not. The chemicals are not getting hotter. The surroundings are getting hotter because there's energy being released when bonds are broken here and remade here. Right? And that's another lesson that we'll go into in a bit more detail. But all you need to remember for now is that when you see a minus symbol, that is energy being released to the environment. So you'll feel a temperature change. Okay, that means that a temperature will go up. Okay, when you see that negative symbol. Okay, and if you can measure a temperature increase with a thermometer, okay, whilst the chemical reaction's going on, then that means that you've got an exothermic reaction. I will just add though, sometimes you'll feel you'll see a temperature change, but that's because you're heating your reaction with a Bunsen burner. Okay, this needs to be if you're not actually heating it with anything. Okay, that you're getting a temperature increase, and that's an exothermic reaction. So as you'll know, this is a combustion reaction. Okay, and that's a good example of an exothermic reaction, combustion or burning. Okay, they tend to be exothermic reactions. Okay, the majority of reactions, or large proportion of the reactions, tend to be exothermic. These are everywhere. Okay, as you can see, we've got them in when we're burning methane. If you remember, we test for hydrogen gas by trying to light it, and it explodes. It makes a pop. That's an exothermic reaction. All right. So that is what the basics that you need to know about exothermic reactions. Next time we'll have a look at energy profile diagrams. I hope that you understood that. Okay, I hope that you find that easy to understand, and I will see you next time. Bye.